Okay, CE Chem, we're into 2.3 and 2.4 isotopes and relative mass of atoms and molecules. Isotopes are written with a nuclear symbol because they vary in the amount of neutrons that they have. Therefore, their mass varies because protons and neutrons make up the mass. The protons are the identifier. They tell what element we have. So if I have 6 protons, I'm always going to have carbon. But I could have 7 neutrons or 6 neutrons or 8 neutrons. I can have varying amounts of neutrons, but the protons are my identifier. So let's look at a nuclear symbol. Okay, this is how we would write a nuclear symbol. The A on top represents the mass number. That is equal to the protons plus the neutrons. The bottom number here, Z, represents the atomic number. The atomic number is the number that you'll see on the periodic table that identifies the elements. For instance, 1 is hydrogen, 2 is helium, 3 is lithium. So that is the number of protons. So you can see if you take A minus Z, you can get the number of neutrons. So an isotope is basically the same, has the same number of protons. So Z is always the same, but different number of neutrons. So A is different. The symbol will always be the same, E, and I didn't tell you what that is, but that is actually the symbol of the element. Okay, so isotopes just vary in the amount of neutrons they have. Let's do some examples. Okay, this is 1,1H, meaning I have 1 proton. And if I subtract the bottom number from the top, I get 0 neutrons. Now, if I take the symbol 2,1H, then I get 1 proton still, but 2 minus 1 gives me 1 neutron. This is known as deuterium. It's part of heavy water. If I have 3,1 hydrogen, then I'm going to have 1 proton still because it's still hydrogen, but 3 minus 1 is 2 neutrons. So here I have 2 neutrons. This one right here is known as tritium. These are all isotopes of hydrogen. Every element has isotopes. Okay, let's do some examples here. Let's do A. What are the mass number, atomic number, and isotopic symbol, or nuclear symbol, for an atom that contains 7 protons and 8 neutrons? So, we are going to take as the symbol E, because we don't know what it is, and as atomic number, that's the number of protons, that's 7, so we're going to put 7 on the bottom. And we know the protons plus the neutrons give us the mass number, so 7 plus 8 is 15, and that is the number that goes on top. So this is the answer for A. Let's look at B. How many neutrons are contained in an atom of nickel-60? Well, if I look up nickel, and I always like to go ahead and write it in isotopic symbol or nuclear symbol, nickel is Ni. And looking on the periodic table or in the back of your book, you can find out that nickel is number 28 on the periodic table. That means it has 28 protons, so we put 28 on the bottom. Now, To get the number on top, they've actually already given it to us here. That's 60. So we're going to make sure that we use that 60 on top. That 60 is the mass number plus of the protons plus the neutrons. So we're going to put 60 here on top. Now it wants to know how many neutrons. Remember, all I have to do is take 60 minus 28, and that gives me 32 neutrons. And that's my answer for B. Going on to C, how many protons and how many neutrons are contained in an atom with a mass number of 26 and the symbol Mg? So again, I like to set up my isotopic symbol or nuclear symbol and put Mg. I know the mass number is 26, so I'm going to put it on top. Then I'm going to look at the back of the book, your textbook, or on a periodic table and find out what number magnesium is. Be careful that you don't look up manganese because it's a different number. Magnesium is 12, so that's the atomic number that goes down here. Now I can quickly say, oh, there are 12 protons, and if I take 26 minus 12, I can say there are 14 neutrons. And I'm done. I hope that's pretty easy for you and it works really fast. Okay, this chart from earlier sort of helps us. Relative masses on the periodic table are just that, they're relative. If we were to use these very, very small numbers, for instance, for one proton, that would be equal to hydrogen, right? Because one hydrogen, that's the mass that would be. Well, instead of using these very, very small numbers, we do what's called a relative mass, and we compare them to each other. So let's look at that. Okay, so if we took helium's atomic mass from the periodic table and hydrogen's atomic mass from the periodic table, let's see what happens. We'd end up with 4.003 divided by 1.008, which is about 4 times. If you want to get technical from your calculator, it would be 3.971. But it's basically 4. So we can say the helium atoms are basically about 4 times as massive as the hydrogen ions. Okay, let's look at a couple others. Let's take calcium's atom mass divided by neon's atom mass. And we should get here 40.08 divided by 20.18, which is about 2. If you want to get technical again, it's 1.986. So we can basically say calcium's atom mass is about 2 times that of neon's. Now in each case we've been able to determine the relationship between the masses of the atoms without actually using the actual masses. Now if we were to do the actual masses, we'd end up with the same ratio. Let's look at that. So with the actual weights, we get the exact same numbers, and there too. So you can see that the relationship between them is the same. Now we use the bigger numbers because they're easier to work with than these really, really small numbers. Okay, so we're using relative masses on the periodic table. We refer to them as atomic mass units so that we can compare them to each other. Okay, so if we were to look at calcium and neon on a teeter-totter, basically we'd want to know how many on each side we need to do. Well, we'd need, for every 1 calcium, we'd need 2 neons to balance out the teeter-totter. Now, in the book, it has you visualize this with the teeter-totters. If the teeter-totter doesn't work for you or the seesaw doesn't work for you, that's fine. Just compare the ratios of how many to how many you need. Okay, we have for a practice problem here, how many calcium atoms, and calcium is 40.08, would have to be put on the seesaw to balance 1 bromine, which is 79.90 for the mass, and you can look these masses up on the back. You can see real quickly 79.9 is basically 80 and calcium's 40, so it would take twice as many calciums to make bromine. So here we are on our teeter-totter, and we've got bromine on this side, and he's a heavyweight, so I'm going to need to put 2 calciums on this side to balance it out. So this is our answer for A. On B, we've got helium, and helium's mass from the periodic table is 4.003. And on the other side, they want oxygen, and oxygen's 16.00. We can quickly see that 4 times 4 is 16, so I'm going to take my teeter-totter again, and my heavyweight is oxygen, and I would need 4 heliums on this side to balance it. The last example question is C, how many hydrogens? And hydrogen is 1.008. Would balance 1 carbon atom, and that carbon is C at 12.011. Well, you can see quickly it's going to be 12, right? So teeter-totter, carbons are heavyweight, and we're going to need 12 hydrogens to balance it. Okay, the next thing that comes on the heels of this is molecular weight. In order to find molecular weight, you need to be able to look up the masses of different elements, and you need to times them by what you're given. So on this one we have 6 carbons, so we take 6 times the mass of carbon, which is 12.011, plus 11 times the mass of hydrogen, 1.008, plus 2 times the mass of oxygen, 16.00. We take and then put that in our calculator and we get an answer. Okay, once you get your calculator answer, you should end up with 115.154 for the calculator. But now you need to look back, and this had 3 significant figures after the decimal. This one had 3 and this one only had 2. Since we're using addition, we look at the 2, put our line here. 4 is less than 5, so it goes away, and we report 115.15, and the unit is U, or atomic mass unit. Here is another example. Let's take a look at what we need to do for this. Okay, you need to take 3 times the mass of hydrogen plus phosphorus plus 4 times the mass of oxygen. Put that into your calculator, and your calculator answer is 97.994. You look and see that it's 2 after the decimal for the last 2 and 3 after for the third one, or for the first one. So you can only go to 2 after the decimal. Again, it's 4, so it goes away. And your final answer is 97.99 U, atomic mass units. That's the end of this last section, so we'll see you in class.